Hello, welcome to the electronic home workshop. As you can see today in the workshop, we are going to deal with transistor to demonstrate latching. This is the theory aspect of latching. Since in the previous video, we use a relay to demonstrate latching, where we use two forces, the force of the spring and the force of the magnetic field created by the solenoid. But in this particular circuit where we are going to use transistor, we are not going to use a forces, any force to create a torque. What we are using here is that we are using the resistance to create a torque. As you can see also, we have two transistors. Here is transistor 1 and we have transistor 2. We have 5 resistors in this circuit. We have two transistors that are connected to transistor 1 and also another two transistors connected to transistor 2. We have a transistor here which is 100 ohms. The purpose of this resistor here is to limit the flow of current or voltage into the circuit, to make sure that the voltage does not exceed the normal operating current. Now we have two transistors here connected to T1, that is transistor 2. We have 1K and then we have 10K. We also have two transistors here. This is 1K and 2 and 10K as well. So both transistors are equal to each of these transistors. The lead, of course, have also a resistance. The transistors themselves have a resistance, but they are the same kind of transistor. So therefore, their resistance inside, or their both resistance, are actually equal. So as you can see that we have two resistors here and two resistors here, and they are actually equal. So the resistance of these transistors and also this transistor are equal. So in this case, you are now able to create a torque. Now, what you should know here is this. If you power the circuit, what will you actually observe? You will observe that automatically one of these leads will be switched on, or one of these transistors will be directly or automatically switched on. But in case you power the transistor, the circuit, and both of these leads or the transistor are switched on, that simply means that there are more voltage. The voltage are too much in the circuit. The circuit have more than enough voltage to operate the circuit. That is the reason why you are seeing both lead is actually on. And the other reason here is that if both transistors are switched on or both leads are switched on, that means the resistance are not actually equal, they are not balanced, because as the transistor has equal resistance, then when you power the circuit, the whole voltage will flow into one transistor, leaving deficient voltage in a circuit. One of the transistor that is going to switch on will actually allow a larger voltage to flow on. Let's say if transistor 2 is switched on, transistor 2 is going to allow all the voltage or more than half of the voltage to pass through this transistor, leaving deficient a very small voltage into the circuit so that that voltage will not switch on transistor 2. I mean transistor 1. It is only transistor 2 that will be switched on. But if this transistor is switched on and the transistor pass a certain amount of voltage and there is still enough voltage here, this voltage is also going to switch on this transistor T1. Therefore, there is going to be the two lead switch on. You will have these two lead switch on when there is more voltage, because if one transistor is on, more than half of the voltage is going to pass through here, so that the little voltage that is going to remain in this circuit will not be enough to switch on this other transistor. But if this voltage passing through here is somehow equals to the voltage that left into the circuit, that voltage is also going to switch on this transistor so that both of them will be switched on. So for you to avoid that, you have to control the voltage that is coming into the circuit. Now, when you apply a voltage into this circuit, you will find out that one of the lead is going to switch on, or the transistor is going to switch on. Now let's say you input 2.5 volt into the circuit here. Now when you input 2.5 volt into this circuit, at least this transistor is switched on, and therefore this transistor is actually going to allow 2 volts to pass through here. Now 2 volts is coming this way. If 2 volts is coming this way, then what will remain in the voltage in the circuit here is 0.5 volts. The 0.5 volts will be here, but it is not going to be enough to switch on this transistor, because it is not enough. The resistance here is higher, and here too, since this transistor is switched on and the voltage is moving in this direction, this actual resistance is going to be a resistance to the flow of current here. So instead of the current go this way, the current will now come this way into the transistor and then to ground. So therefore, there is not going to be any voltage here, and this will be off completely. Now if you want to latch this transistor, what will it do? You have two options here. One option is to short circuit. Now the voltage is moving in this direction. We have a base voltage here. Now this lead is on. Now since we have a base voltage here, we are going to short circuit this, thereby allowing this base voltage to now shorten to ground, to move to the ground instead of moving in this direction. And we already know that when a voltage is being input to the base of the transistor, the collector emitter resistance actually decreases, meaning the base voltage of a transistor is inversely proportional to the resistance. That is, when you input a voltage to the base of a transistor, the resistance between the collector emitter junctions of a transistor will decrease, thereby allowing a voltage to move from the collector pin to the emitter pin. And if you reduce the base voltage, the resistance between the collector emitter of a transistor will increase, thereby stopping or reducing the amount of voltage flowing through the junctions of the emitter and the collector and the emitter pin. Now, as you short circuited this, the base voltage here now is moving in this direction, meaning there is no voltage flowing here. So definitely the transistor is going to stop the voltage from flowing in this direction. Now, if the voltage is being stopped to flow in this direction, then the voltage is going to take another path. Now, the voltage will come back into the whole circuit here. Some is going to pass in this way and apply to the base voltage of this transistor T2 now. And the moment the base voltage come this way, started moving in this direction to the emitter, the resistance between the collector emitter junction is going to decrease, and thereby allowing now the larger voltage to pass through this point to the ground, causing this transistor to switch on, and this lead will also switch on. So when you open this key again, this is not going to switch off. This is not going to switch on again. It will remain off because the whole voltage now is moving in these directions. You know earlier that when there is torque in a circuit, no movement. When you apply a base voltage and then that voltage allow or causes the transistor to switch on, and when you remove that base current or the latching voltage, you will find out that the lead or the transistor will still remain on despite you have removed the latching voltage or you have opened the key. It will still remain on, meaning you have latched that transistor. Now, when this one is being switched on and now you want to switch off this transistor T2 to actually switch on this transistor T1, what you have to do, since the voltage is now flowing in this direction, you have to short circuit this. When you short circuit, the voltage will now, this base voltage will now pass on to ground, thereby stopping any voltage to flow into here. That will increase the resistance in the transistor, stopping this voltage to flow through the transistor. And when it stops this voltage, the voltage will now take the easiest path because the transistor here has been increased more than this resistance here. The power is now going to move this way, come this way, and then enter into this transistor, thereby allowing switching on this transistor, allowing this voltage to be passing through this transistor. When that happens, this light will be switched on. If you now open this key, this transistor is still going to remain off. It will not switch on. But in case in other circuit, when you actually apply a base voltage here, this transistor is going to switch on. And when you remove that voltage, this transistor is going to automatically will switch off. So that means that the resistance are not equal. The resistance are not balanced actually. They are not balanced. But when they are balanced, the moment you apply a switching voltage or a latching voltage and then you remove that latching voltage, that transistor is still going to be switched on. That means that the resistance of both transistors are equal. Don't forget, this is just the theory aspect of this project. We will actually see the practical aspect where we will see the physical component. We will see the physical transistor, resistor, and the lead. Remember that we use a USB charger, 5 volts, which is mobile charger to power this circuit. Now let's go to the practical aspect or the practical demonstrations of um, the transistor latching circuit. Now, this is actually the transistor, the physical transistor circuit, where you are going to see the physical operation of this circuit. Now, as you see early in the theory and circuit, you see that we have two leads here. We also have two transistors. These transistors are actually 10K, and then we have 1K here and 1K here. This is 1000 ohms, and this is also is 1000 ohms. This is 10,000 ohms. This is 10,000 ohms. Now we have the lead, and then we have the two transistor. As I said earlier, when you switch on this circuit, one of the lead will automatically switch on. That is because the torque has been created. There is not going to move, there is not going to be any movement in the circuit unless you manually latch this circuit before you can switch on and off the transistor or the lead alternately. Now let me power the circuit to see how it actually operates, how we will use this to latch the transistor. Remember that we are using 5 volts. We are using 5 volts to power this circuit. This is a 5 volt power circuit. Here we are using a DC phone charger, 5 volt DC phone charger USB. Now let me power the circuit and see what actually will happen. Now as we definitely switch on the circuit, one of the lead is on. Now the voltage is moving in this direction here. The voltage is moving in this direction. Now if we short circuit this, we will find out that this lead will be off and this lead will automatically switch on. Now let's short circuit and see. Now we short circuit this. Now this lead is off and this lead is now on. Now let me remove the short circuit key and see what will happen. Now I remove it. You see, it still remain on. This lead does not switch on back. It still remain off despite I have removed the short circuit key. That means you have latched the transistor, and this is a transistor circuit. This is how to build a transistor. If you switch on the transistor, this circuit, if you make any circuit and then you switch it off, and you switch it on, and both lead comes on, they switch on, that simply means there are enough voltage in the circuit. You have to use a transistor to limit the flow of voltage into the circuit so that the normal operating voltage will be actually maintained. Now, in case you switch on this circuit and then one lead is on, and then when you apply a base voltage and this lead will switch on, and then when that base voltage or the latching voltage is being removed, you remove this pin from the pin and this light is switched on back, then that means the resistance are not equal. But when the resistance are equal, the moment you use this pin, this short circuit, and then you switch on this and then you remove it again, this will be still stay on. Let's see. Now I apply this short circuit here because this is now on, so I'm going to remove the voltage that is here to ground. Now you see I have removed there is no voltage now into the base of this transistor. The voltage is now moving into this um into ground here, so there is no voltage here. So what will you think will happen? This light, this lead has not been switched on. Now let me remove this short circuit and see if this light, this lead will switch on back. Now I remove it, it doesn't switch on back. So what happens here is that we have actually latched a transistor and we created a torque in both transistors that are equal to each other. Now let's do the action repeatedly and see how it works. A latch, the latch on and off, the latch on and off, the latch on and off, the latch on and off. That is exactly how we will use a transistor to practically demonstrate latching. In this video, actually, I will tell you in the workshop or from the workshop that we have done with latching. The next project is actually going to be how to create a key to switch, to manually switch on the circuit on and off. We are going to see how we can create two buttons to switch both transistor on and off. We will also create a key or a switch that you will use to a single switch. Here we are going to use a double switch, where you will use one to switch it off and you will use the other to switch it on. In the other side, we are going to create a switch, just a single switch that you will use to operate the circuit on and off, just a single switch. You will press the button and it will switch on, and then you will press the same button and it will also switch off. Thank you very much for watching this video. Don't forget to subscribe. Thank you. Thank you.